Question 8 offers us a trig identity question. We've got to prove that the left-hand side, all in cosec, equals this simpler equation on the right in tan and sec. So here I've set up my left-hand side, right-hand side. I like to muck the right-hand side around just to give me alternatives, because as I work through this, I might spot that, oh yes, that's the direction I need to go in. So let's just move this around a little bit and just see the variations we've got here. Now tan is sine theta over cos theta, and sec can be transformed also into 1 over cos theta. So this is equal to 2 sine theta over cos squared theta. I think the next big difference to recognise is that the right-hand side is a single term and the left-hand side here has 2 separate terms. So we should attempt to put this on a common denominator. And the common denominator will be the multiplication of both these 2 terms. So if we work this out just as if they were numbers, I get cosec theta plus 1 plus cosec theta minus 1 on the numerator. These 2 terms cancel each other out, and I'm left with 2 cosec theta on the top, and the denominator we've got to multiply out. So this is cosec squared theta minus 1, and the bottom 2 terms will cancel out. So this is looking a lot nicer. So the numerator, cosec, is 1 over sine. So this is 1 over sine theta, and that's 1 over sine squared theta minus 1. So leaving the numerator alone for the moment, this is 2 1 over sine theta. Put these on a common denominator of sine squared theta, and I get 1 minus sine squared theta. So if you're happy with this being a 4-layer fraction, that sine theta will cancel out with one of these. So this is equal to 2. 1 minus sine squared theta is cos squared theta, and that's divided by a sine theta. And that is equal to, if we multiply by the upside down version of that fraction, this is equal to 2 sine theta divided by cos squared theta. And as you can see, we are there because the right-hand side is identical to the left-hand side. So we've proved it. Now we've got to solve this new equation for x between 0 and 90 degrees. And you can see that the left-hand side of this new equation is the same as the left-hand side of the old identity we've just proved, except for the fact that theta is 2x. So if I substitute theta as 2x, I can equate the left-hand side to what we've proved in part A. So I can say that 2 tan 2x multiplied by sec 2x is equal to cot 2x sec 2x. So we've got a sec 2x and a sec 2x on both sides of the equation. Now normally we would cancel these out, but in fact this is a solution because it could be that sec 2x equals 0, and that's a perfectly good result to satisfy this equation. So we'll keep that in storage. But let's go on. What remains? Well, cot 2x is 1 over tan 2x. So I can say therefore that tan squared 2x equals a half. The 2 being here, and we divide through both sides by 2. So taking a square root, I can say that tan 2x is equal to plus or minus 1 over root 2. And remember, we need to do these solutions from x is equal to 0 up to 90 degrees. Well, if I look at solution 1 first, this is the graph of sec x, and there are no solutions that sec 2x equals 0. So I can say there are no solutions. So we've got 2 options of this second solution. I've got tan 2x is equal to 1 over root 2, and tan 2x is equal to negative 1 over root 2. Now, tan x would normally reach its asymptote at 90 degrees, but because we've done the transformation to tan 2x, this is 45 degrees. So after 45 degrees, the blue line will start again to come up from 0. So if you look the first value up on a calculator, you get that 2x is equal to 35.2 degrees. So therefore, x is equal to 17.6 degrees. And there are no other positive solutions for that between 0 and 90. Now look at the negative solution, where we get a negative 1 over 2 will be this point here. And you can say that x must be equal to 90 minus 17.6 because of all the symmetry involved, and x turns out to be 72.4 degrees. And yes, it is true, you could have done that using the cast diagram, but I considered, because we were only looking for a very small range of values of x between 0 and 90, it was simpler to do it the graphical method. So that's the end of question 8.